Okay, today what we're looking at is our new unit, Unit 4, and the topic is trigonometry. Now, you've studied trigonometry before, and trigonometry is the study of triangles. Okay, so today our goal is going to be, I can use primary trig ratios to find the lengths of the sides of a right triangle. Okay, so primary trig ratios. And you're thinking, well, primary, is there some other ones? Yes, there are things called secondary trig ratios. However, we don't have to study that in grade 11. You get to study that in grade 12 math. Okay, so first of all, 4.1, use trigonometry to find side lengths. Okay, so first of all, in any right triangle, we name the sides by their relationship with one of the non-right angles. In the following triangle, the non-right angle we have chosen has been labeled with this symbol here, and we pronounce that theta. Now, theta is actually a Greek letter. Okay, so it's actually pronounced theta. And as I said, it is a Greek letter, and we use a lot of Greek letters in science and in math. Okay, so first of all, we label them according to theta, and the way we label them is we label them using opposite, adjacent, and hypotenuse. Now, some of you maybe do not label. However, I highly recommend that you use O, A, and H for your sides because it's going to make a huge difference to you. So our opposite is going to be opposite of our theta. So for any right triangle that has an angle the same as theta, the ratios of the side lengths will always be the same and are defined as, and we'll do that in a second. So here is my theta. So that is the important angle that we're concerned with. So our side lengths are labeled according to that angle theta. So opposite of theta is literally the opposite side from it. So that would be this one. And I'm going to actually flip mine if I can. So that is opposite side. Opposite of the right angle is our hypotenuse. And I'm going to turn that around as well. And then what we're left with is adjacent. Okay, and obviously adjacent will be located in this triangle at the bottom. Okay, so to be perfectly honest with you, what I do is as soon as I see the theta I'm concerned about, I literally go and either with my pen or marker or pen, sorry about that, I touched the wrong button. So I literally go and I find the right angle and I take my either my I, which is going straight across, and I put H for hypotenuse. I find my theta and I put O for opposite, and then I know the other one has to be adjacent. So I automatically do that. It takes less than 3 seconds, and within those 3 seconds, then I can have my triangle labeled correctly. Because if you don't label it correctly, you're just not going to have, you have no success at getting the question correct. So sine theta is, and you maybe remember SOHCAHTOA stands, we usually use so, and I've lost my writing. We usually write so. So if I have so, that means that the ratio, and ratio can be written as a dividing, and that's what it is here, is opposite over H stands for hypotenuse. Then if we look at cos, cos the short form, so ca. So then what we use for that, we use adjacent over hypotenuse. And finally, tan is, and why will you not do an E for me? Tan is toa, and that stands for opposite over adjacent. Okay, so that's why they made you memorize in previous years SOHCAHTOA, because that gave you a way to remember these three formulas, because that's what we use them as formulas. So, continuing on with our lesson, when you use trig ratios, you must always choose and an angle first. Okay, you have to have an angle first in order to label opposite and adjacent. Yes, you can put hypotenuse where it is, but you need to know the angle. And it will either be the angle you intend to use to find a side or the angle you are trying to find the value of. It'll be one or the other. Now for today, what we're going to be doing is we're going to be using trigonometry to find the sides in a triangle. Okay, so we're not finding angles, we're finding sides today. So let's look at the first example. It says, and this example is one type, and the type that it's looking at, it has to do with finding the unknown when it's the numerator in a ratio. Now, I don't worry too much about whether I'm finding a side that's the numerator or the denominator, because the same steps apply in either case. So find the indicated side length. So here we have our triangle. Now, some people handle it a little bit differently. So the first thing that we're going to do, and I have it written behind here, is first we're going to circle the angle you are using, then label the sides as opposite, adjacent, or hypotenuse. Determine which ratio you need to use and set up the ratio. So that's the step that we go through. So if we follow that, and I'm now going to go back to my question, what it says that I need to do first is to circle the angle that I am using to label the triangle. Okay, so obviously this is the angle they gave me. That's the one I'm going to use. So again, it takes 3 seconds. Hypotenuse, my angle across, opposite, which means this side must be the adjacent. Now I need to determine whether I'm using so, ka, or toa. Now, some people have difficulty with this, so I'm going to show you a little trick that works for me sometimes. I can see that I want to find x. X is the opposite side, so I'm going to just underline all the O's. And the side they gave me was the hypotenuse. Now you can see with these three formulas, I have, this is the one that I have 2 underlined. So it will always work out that way, that if I underline the side I want and the side that I know, it will be the one that has 2 underlined. Okay, so that is what I'm going to use. I'm going to use sine. So I'm going to write down its little formula, and it goes sine of a theta equals opposite over adjacent. There's my formula, a matter of substituting in. My theta is 27, so I have sine of 27 degrees equals opposite, which is my x, over hypotenuse, which is 25. Now this is set up that I can actually create a cross multiplying situation, and that's what I'm going to do. I'm going to cross multiply by first of all getting that out of my way, which it's not doing. I'm going to multiply those two together with those two together. So let's try that now. And I wish it would just stay at what I set it at. So I'm going to have 1 times x is going to equal 25 times sine of 27. 25 times the sine of 27 degrees. Now you literally could go 1 time so you can see that. So all I need to do now is bring up my calculator and actually calculate this. Now you can see I brought up a graphing calculator, and the reason I did that is sometimes you guys use my graphing calculator and it won't give you the right answer. The reason being is, yes, I've got everything cleared, the memory cleared, but the mode of my calculator is not set to degrees. So in the graphing calculator, I actually have to go and set it like this to make it work. So it's really important that you have your calculator set to degrees. So now I have this graphing calculator set to degrees. So I'm literally going to go 25 times, for this calculator, sine of 27. Now, some people's calculator work a little bit different. You might have to do 25 times 27 sine. So please make sure you bring your calculator to class and you understand exactly how it does work. So I end up with 11.3. So that's how that works. Now, some people like to do an alternative way because actually that sine of 27 actually is a number. So if I actually just took my graphing calculator and said, okay, graphing calculator, I want you to actually determine what the sine of 27 is. And it will give me the ratio between the sides. And in this case, it's decimal 45399, which would round to decimal 4540, because if I'm going to use the ratio like this and not type it all into my calculator, I always want to make sure I have 4 decimal places. And I'll write that down in a second. So an alternative way to do this, and I'll just run it over here, is some people literally take the sine of 27 and actually turn it into the decimal that it is, and they go 0.4540 equals x over 25. Okay, because that is what this equals. This is the sine of 27. And then they actually do the multiplying. I want x by itself, so I'm going to multiply both sides by 25. So it works exactly the same way, and you still end up with the exact same answer. Okay, so remember that when you have the sine of an angle, that actually is a number. Okay, and so you do end up with that being 11.3. So again, if I'm going to use uh, my ratio, it's very important to note, leave all ratios rounded to 4 decimal places. Now, the reason we do 4 decimal places is then our answers will always be the same, whether I use all the decimals or whether I use 4. Okay, especially if I'm rounding my final answer to 1 decimal place, I will never have an issue then. Okay, so that's just important to kind of note. Okay, now years ago, before we were allowed to use calculators in school, the only way to actually calculate the sine of 27 degrees is you literally would have to go and look it up in a chart and figure out what it would be. Okay, so that's the first example. I'm going to stop the video and we'll do one more.